In this video, let's look at how to repair a Makita pressure washer. It has overheated and stopped working. There's only a faint humming sound, and the motor is very tight when trying to rotate it by hand. This is the pipe that goes to the gun. It seems to have tightened to the point where it can't be moved, either because of heat or due to not being serviced for a long time. If we apply more force, there's a chance it might break. Let's check if it's possible to repair it without disassembling. First, disassemble the pump from the cover. Here, the motor is placed inside a plastic lock and secured with a cable tie. The back cover needs to be removed. It has been installed for cooling and fan protection. As air is drawn from the outside and passes through it, the motor will cool down. Initially, it was difficult to rotate the motor by hand, but after some effort, it rotates somewhat now, though it still tightens at one point. For convenience, the motor can be fully removed from the cover. The base securing the motor can be detached, and the motor placed into it. Otherwise, the motor won't stand upright. When tapping with a screwdriver, it becomes clear that the motor is tight. Remove the pump head using an Allen key or socket set. Be cautious as there is a spring underneath, so hold it carefully while disassembling, or it may pop out and hit your face. Also, there will be oil. Pour all the oil into a bowl. This is the thrust bearing, which we discussed in detail in a previous video. Remove and clean the thrust plate. Wipe the thrust plate and set it aside. Next, remove the back cover of the motor and check by gently rotating it. After removing the pump head, the rotation becomes easier, which is why we dismantled it before checking if the motor had any faults. Let's power it on and see. When powered on, it doesn't rotate, but you can hear a humming sound. This usually happens when the motor is stuck, but here it's not stuck. When gently tapped with a screwdriver, it rotates, which means it cannot self-start. Most likely, the capacitor or auxiliary winding is faulty. Disconnect the electrical connections containing the capacitor. Let's remove the capacitor and try running it again. If the winding is damaged, there will be a burnt smell. Here, there are no signs of the coil being burnt. The coil winding continuity is fine. Pull the connector from the capacitor terminal. Remove the capacitor. Then close the box securely to prevent any wires from short-circuiting. After checking all the connections once again, turn the power back on. You can see that the motor still isn't running on its own as before. This means that the capacitor has no effect on the circuit. Visibly, the coil isn't burned either. This is the rubber ring that prevents water from entering inside. It needs to be kept safe. This is a 16 microfarad 450 volt capacitor. Now, let's dismantle the auto cutoff switch box. This is the mechanism that automatically turns off the motor when the gun is closed. Before disassembling it, we need to remove a lock that is in place. Inside it is a linkage shaft. When the water pressure increases over a set pressure, this mechanical link pushes the switch, which turns off the motor. Therefore, it needs to be handled carefully and kept safe. These are 3 pistons, which pump water at high pressure. Let's disassemble all of these. It is very difficult to remove this piston, which may be causing the motor to get stuck. Oh, this has really melted and stuck. This is the lock that keeps the spring from flying out. Despite a lot of effort, the piston is not coming out. It has become stuck due to melting caused by high temperatures. Anyway, remove the spring and lock. This black part is the oil seal, which has melted and caused the piston to get stuck, which in turn caused the motor failure. To remove all these oil seals, we need to remove the valve head as well. To make removal easier, reattach it to the motor, otherwise, we may need to use a vise to get a proper grip. Now, let's dismantle the part where the valves are seated. For that, the 3 screws on top need to be removed. These are also tightly fastened. Oh, it's not just the screws, the entire unit is stuck. So, let's try tapping it lightly with a hammer without applying too much force. It's not working. Now, let's dismantle it and try tapping it downwards with the hammer. After tapping and pulling, it finally came off. This is the swash plate, also known as the wobble plate. Oil will be filled inside this. The wobble disc and the thrust plate above it push the piston upwards and downwards, which is immersed in this oil. Wow, this is all dirt. The mud from water, aluminum oxide, leaked oil, rust, and parts of rubber have all combined to create this mess. Let's get back to the pump. Looking at the winding, it doesn't seem burned, otherwise, it would have been charred. In that case, the capacitor would have been the issue. After connecting a new capacitor with the same rating and powering it on again, the motor is now rotating on its own, indicating the capacitor was the problem, not the winding. When the switch is turned on, it spins on its own. Moreover, it only rotates in one direction. Although we removed all the pistons, the oil seals were still in place. Use a blunt screwdriver to gently push out the oil seals. However, here they seem to be stuck due to melting and rusting. Despite much effort, they aren't budging. We can try applying some WD-40 and leave it for a while before attempting again. Let's leave that aside and check the valve head. This is where the water seals and valves are located. First, remove the spacers. Be sure to use a screwdriver without a sharp edge. If the wall gets scratched, water and oil may leak. There's no major issue with the seals, but it's better to replace everything together when changing. Use an Allen hex bit socket 3 to remove the upper head. Be careful when removing the pipe. There is a rubber ring at the bottom. It should be kept intact, or else there will be a water leak. These are the 3 inlet valves. Let's remove the output unit. These are the outlet valves. All the O-rings are flat and need to be replaced. Now, let's disassemble the valves. If there is any damage, it will also need to be replaced. Do not use tools with sharp edges. While removing the valve, be gentle and cautious. The valves don't appear to be damaged. The spring action is correct. Check all the valves and put them back in place. None of its videos are shown here. Let's remove the oil seals. Even after applying WD-40, they are still very tight and have melted together. Be careful not to let the tip of the screwdriver touch the aluminum parts. The seals broke and the spring came out. Finally, everything was disassembled. These are the oil seals that caused the problem. These 3 are the new water seals. Although there isn't much wrong with the old water seals, it's best to replace all of them together. Each seal should be properly lubricated before securing them in their respective positions. Ensure that they are fully seated inside. Do not use any sharp objects to push the seals. If needed, you can use a piece of wood. When placing the spacers, the grooved side should be facing upwards. let's secure the oil seals. Clean the area well and wipe off any remaining dirt. To clean the aluminum, use a non-abrasive cleaner such as a mixture of vinegar and water or specialized aluminum cleaners. Scrub gently with a soft brush to avoid scratching the surface. Regular maintenance and cleaning can help reduce the buildup of corrosive materials. Unfortunately, the original oil seals are not available, so we'll be using compatible, high-quality replacements with the same specifications. These seals should also be lubricated before being secured into place. As with the water seal, try to install this by hand as much as possible here. Otherwise, you can use a wooden piece. Since it will take time to get the spares, the oil and bearings have been refilled in it again. We'll thoroughly clean the oil chamber. The wobble plate needs to be removed and cleaned as well. This component here is the motor's bearing. Cleaning this well will increase the motor's lifespan. Pay attention to the notch on the shaft. The wobble plate is mounted onto this. It helps the plate rotate without slipping. After cleaning everything, reassemble all the parts in the correct order. Start by placing the wobble plate, ensuring it fits into the groove properly. On top of that, place the thrust plate assembly. This consists of 3 parts, the upper and lower plates, and a ring with steel balls. Make sure that the parts rotate smoothly. Now comes the slightly tricky part. Carefully reassemble the springs and pistons, ensuring that the lock doesn't reverse. This lock keeps the spring secured in the piston, preventing it from popping out. The bottom part of the lock must be placed without shifting its position. Slowly push the piston inward. Ensure that the edge of the oil seal does not get pinched with the piston. The melted rubber has been cleaned, but not fully removed. Rubbing the piston with anything could leave scratches, which might lead to oil leaks. The oil seal is stuck on this piston. The rubber parts are tightly adhered to it. We can clean it once again. Spray WD-40, then gently wipe the surface. Afterward, use a cotton cloth to remove any remaining rubber residue. Now, most of the dirt on the piston is gone. Don't forget to lubricate the piston. Fill the oil. Use SAE 30, single grade, non-detergent based oil. Pour Pour enough oil to submerge the thrust plate. If too much oil is added, it can expand as it heats up during operation, causing the seal to burst and come out. Place the piston unit back in, ensuring the spring doesn't slip inside. Otherwise, parts inside could get damaged when powered on. Due to the spring action, you'll need to apply force to hold it down while tightening the screws. Tighten all the screws alternately instead of fully tightening one at a time. Since there's a spring underneath, one side may lift. After assembling, rotate it to check if everything is smooth. If not assembled properly, it'll be difficult to rotate, or you may hear a cracking sound. Ensure that all 3 pistons move smoothly up and down. These are the new O-rings. After thoroughly cleaning, lubricate and place the new O-rings back in their correct slots. When placing new O-rings, use only your hands, not a screwdriver. However, you can use a blunt screwdriver to remove the old ones. Ensure the O-rings are fully seated in their slots. If they are not seated properly, they may get pinched while tightening and could break. After lubricating the piston again, carefully place the upper part. Ensure that the O-ring at the end of this pipe is present, or else water will leak. Let's finish the electrical connections. The new capacitor is not a plug type. Its value is 18 microfarads. Replacing the 16 microfarads with an 18 microfarad capacitor won't be a problem. The cap needs to be removed, or it won't fit inside. Don't forget to place the O-ring to prevent water from entering. The terminal tab of the old capacitor was removed and connected to the new capacitor's wire, allowing the motor's female connector to be used without cutting it. Now, wrap it tightly with tape and tuck it inside carefully. Finally, clean and secure the last part properly. Check the auto cutoff switch, make the connection, and secure it in its proper position inside the box. Place the shaft in the middle with an O-ring. Without this, the motor won't turn off when the gun is closed. If the small O-ring is missing, water may leak into the switch, leading to an electric shock. Install the lock, or it may come loose over time. Lastly, check once again if the motor is running properly. Listen for any unusual sounds. Now, connect the pipe and check if the pressure is correct. Also, verify if the auto cutoff is working. If you enjoyed this video, please like, subscribe, and share. Thank you very much.